Welcome. A very, very, very good evening, ladies and gentlemen. Welcome to the monthly technical meeting organized by the Society of Petroleum Engineers Abuja section. Thank you for being part of this event. Welcome. We kindly advise that you share this meeting link to all of your colleagues, to all of your friends across all platforms, across all social media platforms, so they can be part of this training. On the call today, we are so pleased to have our amazing, phenomenal speaker who is ready to share knowledge today. The meeting is going to kickstart officially in the next 3 minutes, by 5 minutes past 5. So we want to give all of the participants about 3 minutes to please share the link far and wide so that you may have a very, very interesting event. Once again, welcome. Please share the link. We had over 40 participants registered for this event, and we believe that all of us will join, and of course, we add our friends to the call. Once again, welcome. In 5 minutes, we'll kickstart officially. But before we kickstart in 5 minutes, can you do me a favor? Kindly head over to the chat button, drop where you're joining us from and what you hope to gain from today's event. Go to the chat button, drop where you're joining us from. Are you joining from Abuja? Are you joining from Lagos, Nigeria? Are you even joining from outside Nigeria? Just do that favor. Kindly head over to the chat, drop where you're joining us from and what you hope to gain from today's event. We'll be so pleased to read it. And then in 5 minutes, we can start. In the 5 minutes past 5. Thank you, and thank you so much. Kindly head back to the chat box. Let us know where you're joining us from. We'd love to read, where you are joining us from. Probably what you want to learn from today's event. Okay? Expecting that I'm going to read a lot of chats right now. Okay, welcome. Please, like I said earlier on, kindly share the link to all of your colleagues. We'll be so pleased to have as many participants as possible. We learn from Nobel Reza. Thank you so much. Okay, let me read the chat. The Zok says he's joining from Abuja, Nigeria. Of course, the Zok is interested in finding out how AI would enhance his practice and what applications are immediately deployable. Awesome, Dazok. Dazok, I assure you that you're going to have all of that knowledge today. Welcome, Dazok. Okay, so why are you joining us? Let's know. One more comment. Where are you joining us from, and why are you part of today's monthly technical meeting organized by the Society of Petroleum Engineers Abuja section? Okay. So while we wait for your comments, and of course, while we wait for more participants, we continue the event by making us understand that we have very phenomenal personalities on the call with us. Of course, on the call, we have our speaker for today, a man that has volunteered his energy, his resources, his experience to speak to us for about 55 minutes and, of course, answer questions. Ladies and gentlemen, please let's welcome Nobel Bariza, a petroleum engineer and tech enthusiast who is on the call. Welcome, sir. We celebrate you, sir.
Thank you very much, and good evening, everybody. Welcome to this session.
Okay. Still on the call, we are so pleased to have the programs chair of the Society of Petroleum Engineers Abuja sector. Welcome, Dr. Ikechukwu Akafo. Welcome, sir. It's a pleasure to have you here.
Good evening, everybody. Welcome to the session. Thank you.
Okay, we have several of our senior members here. I can see Mr. Thank God Egbe is on the call. Welcome, sir. We celebrate you, sir. Welcome, Engineer Thank God Egbe. Welcome, sir. If you can hear me, sir. Okay. We also welcome all participants, all our student members, and everybody that has joined today's monthly technical session. If you can see your screen, you see the order of event for today. We are starting this event with a safety brief. After the safety brief, we'll have a welcome address by our programs chair, and then we introduce the speaker who will handle the session for 45 minutes. And then we have a question and answer session. And of course, we have a closing remark and we have the opportunity to network. So I'm saying welcome, and it's going to be very short, very interesting, very interactive. And believe you me, you will learn so much. Safety brief. Please, for the course of this event, we kindly appeal that you leave your microphone on mute so that you may not interfere with the deliberations we may have today. I also advise that if you're driving, you leave and park your car in a safe parking space so as not to have an accident. And finally, if you're using a mobile device, please ensure that you don't carry your mobile device to your kitchen so as not to have an LPG explosion. We believe we are going to have a very safe celebration throughout the next 1 hour and 30 minutes. Switching gears immediately, ladies and gentlemen, would like to have the welcome remark. Of course, the welcome address will be taken by no other than one of our leaders in the section, one of the most hardworking program chairs SP Nigeria would ever have, the phenomenal Dr. Ikechukwu Okafor. So please, the stage is yours for your welcome address.
Okay, thank you, Akman. Can you hear me?
Loud and clear, sir.
Okay, good evening, everybody. It's my pleasure to have you all here. And on behalf of SB Abuja section and the members of the board, first, I want to welcome the speaker, my friend and brother, Nobel Valida. Thank you for accepting to give us this technical talk today. It's actually a pleasure to always listen to you. And to everyone on the call, you're welcome. We are hoping and we're very sure that this short moment will open us to the opportunities of what AI can do, actually as it concerns drilling. We're hoping our speaker would make it as interesting as possible and all of us will have something to write home about. Thank you once more and thank you for joining us.
Thank you, programs chair, for that very brief, of course, very decisive welcome remark. So, ladies and gentlemen, yes, immediately to the session. Of course, if you can see the screen, you will see the synopsis for today's event. Of course, the presentation provides a comprehensive overview of how artificial intelligence is revolutionizing the drilling sector of the oil and gas industry. Because a speaker is going to do an extensive job making us understand how AI-powered drilling is giving us a transformational look ahead. We're going to switch gears by making us know who this speaker is. Of course, the speaker is an accomplished petroleum engineer and tech enthusiast with over 25 years of experience spanning various upstream oil and gas operations, including drilling, production optimization, and product coordination. Currently pursuing his PhD in oil and gas engineering with a focus on AI applications in drilling mechanics to drive innovation in the industry. As a company man, demonstrated strength in leading drilling teams, overseeing rig operations, implementing new technologies, and spearheading complex drilling projects like multilateral wells and short radius sidetracks in brownfields, commended for optimizing processes, reducing costs, and maintaining the highest safety standards. While working as a petroleum production coordinator, he excelled at reservoir modeling, forecasting, and driving collaboration between engineers, geologists, and a field personnel for data-driven reservoir management. He played a key role in estimating reserves, planning well interventions, and assessing project viability. Earlier in his career, he contributed to developing pioneering sustainable technologies, including thermally activated mud emulsion stain as a cost-effective and eco-friendly alternatives to oil-based muds. He championed drilling, cutting, reinjection technology to align with environmental regulations in the Niger Delta. He is known for a strategic mindset, technical expertise, and firm commitments to environmental sustainability, adept to leveraging data analytics, simulations, and technologies like MATLAB and Halliburton landmark software to drive productivity. Of course, he's recognized with several awards for contributions to the oil and gas industry, education, and local communities. He's eager to continue advancing the intersection of petroleum engineering and artificial intelligence to spearhead solutions of enhanced efficiency, safety, sustainability, and process optimization. He aspires to drive research and development efforts that will revolutionize the industry's practices and environmental impacts. Ladies and gentlemen, for the next 45 minutes, you'll be listening to a petroleum engineer and tech enthusiast, the one and only Nubo Bariza. Of course, after his session, you have few minutes, about 10 minutes to ask a question. So we advise you jot down your questions throughout the course of his presentation. At this juncture, ladies and gentlemen, I hand over the stage to Nubo Bariza. So please, the stage is yours for your presentation.
Thank you very much. And one more time, good evening, everybody, and welcome to this session. Like I said, my name is Nubel Bariza. I'm a petroleum engineer. I've been like 25 years and over in the industry. I think I've been able to make my mark and establish my drive for tech. So we'll be talking about drilling, basically AI-powered drilling specifically, and how it's going to look like, how it's going to transform the industry starting from today to tomorrow. So I'll go to my slides now. So I'll take it one after the other. Meanwhile, we have a sequence, the sequence of presentation in this session. We basically follow, I'll just do an introduction here, a view of the oil and gas E&P process. We'll be talking about artificial intelligence. I'm going to define what the artificial intelligence is, then look at how it ties to drilling, and then we'll look at the current phase of artificial intelligence in drilling. We'll also look at the novel applications of artificial intelligence in drilling, and then we'll do an example after looking at all the concepts. We'll look at an example, life example, how it can be applied, how it's applied. Now look at its impact and implications in the E&P industry, especially with respect to drilling sector. We'll look at the challenges and do a sneak peek into a look ahead. Of course, I will now conclude the session and then make a few recommendations. So I'll go straight to my slides now, and then we'll pick it up from there. Okay. Okay, am I missing, please?
Yes, sir. I see your slides very well, sir.
Okay. Okay. So this has been said before, is AI powered. The topic for today is AI powered drilling, a transformational look ahead. Like I said, we're going to go through what the core component is, which is artificial intelligence and machine learning. So what is artificial intelligence? Basically, artificial intelligence is just a computer-based system that can perceive, learn, assist in decision making. Yeah. And this entails the deployment of computer protocols that can perform tasks that will typically require human-level intelligence. Cut it short, artificial intelligence is basically making the computer behave like a human being. So what is machine learning? Machine learning is a subset of artificial intelligence that allows the system to learn from data. procedures, learn from data using the procedure terms, algorithms. And this learning, of course, over time improves just like we human beings do. You learn something, you learn to ride the car today. First day, you're not able to reverse, the next day, you're able to reverse. In a couple of months, you're able to speed. So that's what machine learning does in the context of artificial intelligence because of the protocols that have been written, the algorithms. Now, this machine learning uses a certain format called algorithms. Algorithms on their own is a fine sequence of instructions that have been given to the computer, and these instructions are very, very definite. You tell the computer, behave like this, behave like this, behave like this, and that's what the computer now uses to process in the function, acting as artificial intelligence system to give us the feedback that we get as output. Before we go ahead, I want us to just have a big picture, eagle's eye view of the oil and gas industry. For us to even get to a position where we drill, the first thing is things are done before you start drilling. The first thing is you look for the oil. The oil has now been discovered. Number two, you do an appraisal of the oil field. And then after the appraisal of the oil fields, you do a development. That's where drilling now comes in. Of course, when you finish your drilling, you start producing the well. And when you're done with the well, it is abandoned. So today we're going to be looking at 3 developments because that's where drilling completion falls in, which is basically the area we're going to be zooming in. Though artificial intelligence transcends all these facets, but for today's reason, I'll give a global picture, how it affects all of them, but I will not zoom in into drilling to show exactly how it's done using an example. Okay, so first of all, how does artificial intelligence, how does it work? Because the computer learns, the computer does this, the computer gets better. How is it done? I'll give a very simple example. Like I said, it's an algorithm. If you look at the slides here, a certain amount of data is taken, is fed into the system, into the algorithm. When you say the system, now I'm talking about the algorithm. Those sequence of instructions that have been given is called the algorithm. And that algorithm is what you're seeing here. I don't know if you can see my cursor on top. Okay. So you give it to really take the input data depending on what you want to do. For instance, let's say you want to determine the strength of a rock. When you're drilling, you take the parameters that you think are going to be able to give you those values, something like sonic log. You do some experiments, you penetration, you gather all the data that is within your rig that you're going to analyze to get your output as an input. You plug that into the input. It could be 10, it could be 6, it could be 20, it could be 30, it could even be 50 or whatever number. Now, when you plug into the system, the algorithm looks at what impact, the magnitude of impact each of these input has on what you're looking at your output. I'll give you another example. For instance, you're looking at something like the strength of a rock, and you take logs. You take a neutron log, you take spontaneous potential, you take a resistivity log, you take density log, you take sonic log. Everybody knows that spontaneous potential, yeah, it may relate to log properties, but it doesn't really tell you how strong a rock is. The most important thing that tells you the strength of a rock is the sonic log, because we all know sonic log measures time travel within a certain interval. And we know that the denser information is, the faster to be able to push signals through it. If you take a stone and send a signal through, it will travel faster than when you take water and send signal. So the stronger the property, the material, the metrics, the stronger, the faster signal will go. So it has very direct correlation as compared to things like spontaneous potential. It could be scattered. You could have a soft rock with high spontaneous potential. You can also have a strong rock with spontaneous potential. Anyway, it takes these properties and then weights them and ranks them. Most important, less important until it comes to low. Takes all these things now in what is called a neuron and then combines all of them. After summing them up, it gets one singular output from the analysis is done based on the algorithm. And then you introduce what they call the activation function. The activation function, there are several types depending on the type of what we want to do. There are action you're copying, whether you want or you want to determine a picture. Maybe you want to know if it's a dog, a cat, or a human being. So that would depend on the kind of activation function you're going to use. The activation function actually determines what the output is going to be. There are 5 different ones that are most classical. You have this sigmoid, down H, ReLU, leaky ReLU, and the softmax, depending on what you want. And then the activation takes the signal, passes it out, processes it, and puts it as an output. And if it is not exactly what you want, because the algorithm realizes that, no, this is not exactly what I want, it goes back again and repeats the cycle in what they call the epoch, E-P-O-C-H, and keeps doing that. As it's doing that, like we said, it learns, it gets better and gets better until it gets to a point where it says, yes, this is what I want, and then it emits the answer out to you as your output. That's basically how the algorithm works. Below, you can see a simple algorithm. You have an input layer, an output layer, and then the hidden layers where all this processing is done. You don't see it. You input into the input layer, and then you get your answers from the output layer. But all these other things, the feed forwarding and backward, and all the computing that happens within what they call the hidden layer, those are the brown ones you can see there. Now, how does this tie to drilling? Because that's the main thing we are concerned about now. First of all, in the drilling process, we just go through it. You start to drill a well. First of all, you do the well planning, you do the drilling, you do the completion, and then you do the production. At the well planning stage, you have people coming together, all manner of people, from reservoir engineers to the geologists, geophysicists, drilling engineers, gather all their data, synthesizes, depending on what the company philosophy is, and then they come out with the master plan. That master plan, written as a drilling program, is now sent to the rig, where the drillers with numerous skill sets will now start to do the drilling. By the time they finish their drilling, everything's on, they hit the pay zone, the completion people will now come in and complete the well, install all the chandeliers, run the casing, run the tubings, put on all the chandeliers, and once that is done, everything is okay, the well is now put in production and then sent out, and then fluid is now recovered on surface and sold and stored and blah, 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 depending on what the company wants to do with it. The issue is, in this sequence, our concern is, how does AI play a role? Currently, the big picture I've just given you is the sneak of how all these things are done. But how does AI now come in to make the system better? We have to spend time looking at it. And it's simple. 2 ways. First of all, in terms of data-driven decision making, I'll give an example. For instance, when you're planning the well, one of the key things you look at is the overburden. How much weight is above the point that you want to drill? And if this weight is XYZ, how do I make sure that by the time I drill to that point, because don't forget, you're removing rock from a certain point, maybe like 3,000 meters, and in nature, everything tends to neutrality, like we all know. Once you take off that rock, why won't the rock creep in and collapse? Why will the well not creep in and collapse? Definitely it will if you don't do anything. And that's why we run things like casing, okay, to prevent it from collapsing. Now, what AI does in this respect is that lots of sensors have been developed that go into the well in the process of drilling and capture data. It captures the strength of the formation, it captures the fluid content, it captures the conductivity of the formation, it even captures the mud properties from viscosity, it captures the log and a whole range of data. As a matter of fact, all the data you need on the rig that supports the driller's decision. Now AI is able to capture all this barrage of data in one single and split and fast second. That's one. Also, machine learning models also help in analyzing patterns and anomalies. Way back, what you used to do, the reservoir engineers would come up with an underground model, a subsurface model, and we study it and then pass it to the physicists, they combine before they eventually come up with a drilling program. But with AI now, all those models are being seriously analyzed and keenly evaluated in a way that the human knowledge will hardly. And though the human knowledge gives it the instruction to teach, it does it, but the AI has been able to catalyze, magnify that system so that what you do, for instance, in like way back, I want to do, you write the program like in 1 month, AI does it in 2 minutes. Once you feed it all the things and give it the right algorithm, it analyzes and gives you the complete picture in 2 minutes. And that helps you to quickly make a decision as regards to what you want to do, depending on the target and the philosophy of the thing. Then, how does it also affect? We all know that drilling is a very expensive venture. For instance, you're on a rig, you're drilling, and then your top drive fails. Let's say you're offshore. There are rigs offshore that spend as much as $500,000 a day just for rig rates. I'm not talking of consumables. Imagine when you have a downtime on that kind of rig now, and you spend maybe 6 hours. So you're doing $500,000 divided by 24 times 6. That's a whole lot of money. Then with AI and its ability to rigorously capture data on the fly, those kind of situations can be, eliminated. Yeah, because it continuously captures the data that has to do with the integrity, functionality of all the equipment and gives you real-time evaluation. That way, you were able to capture these things and mitigate it before any downtime comes. Automation of processes. With AI, we've all seen that way back. I'll give an example in Nigeria. When the oil companies came to Nigeria, it was Shell Darcy. Shell Darcy had everything. They looked at it, if we drill offshore, it's going to be very expensive. It was cheaper to drill on land. So they sold the offshore assets to Mobil and took the ones that were cheaper because it was land. They did not realize the offshore processes, the offshore assets were even more beneficial. However, with the advancement of technology and automation, and with AI now, it has become very, very relatively easier to deal with situations offshore. We now have things like robotic arms that automate. I remember way back in my former company, Shell, where I started from, we had this project then, Hit the north and hit the south. It was a difficult one. But because of machine ROVs, that project was done and everything paid off normally. Now we have robotic rigs that minimizes contact with man and makes the operations on the rig flawless. All these things are done by artificial intelligence. And at the core of this artificial intelligence is what? Algorithms. It is people that know these projects, that understand the sequenciation, that are written these algorithms and give it to the computers to implement it at a rate that is over 1,000 times faster than the human process. We have a lot of gain there. Yeah, because this data is captured on the fly, unlike way back when you take a data, maybe you scan it or you email it to town, it is evaluated and then sent back to all those things now, a receptacle center, maybe offshore on a vessel or whatever, analyze immediately, the AI does the analysis, the man endorses it, maybe the superintendent, and straight away decisions are taken on the fly. So these are all the current status of what AI has done to the drilling industry to this moment. Now, novel application of AI. Like I said before, cognitive drilling advisory systems. What is cognitive drilling advisory system? That's advisory system, drilling advisory system that can think, reason, and behave like a normal human, though they are electronic systems. And if you look at the schedule, they look at the schematic of, you see the global optimizer, you see the historical data, you see the prediction, you see the high fidelity numerical models. This is what I'm talking about. The petrophysicists and the reservoir engineers get all the data, even from the seismic people, put it to a machine. The AI is able to process it and comes out with a map of what underground looks like. It's passed on, and that is now combined with historical data, and then it still processes there, and eventually predicts what the structure will look at. With this prediction now, look at maybe the one down, the person out there, the petroleum engineer or the drilling engineer is able to now say, okay, if this is what I have, then my best trajectory is this, or this is the best condition I'll adopt to be able to optimize my recovery. There are a whole lot of things that go into it. You can see advanced pattern recognition for the reservoir, apply machine learning on large historical data, identify subtle pattern indicating drilling dysfunctionalities, and then knowledge extraction and retrieval from historical data. These are things for instance, you have a field that lasted for 50 years and you want to put a new well. How will you go and start reading 50 years reports? But with these reports now, you can just capture everything, format it properly, give it to the AI, and split second, it calculates and gives everything and gives you the best output with which you can make your decision, and life becomes easier. It's done. I think this is the one that will give us a really good hands-on. The example here is a situation where there is a need to be able to know the status of the formation downhole when we are drilling. We understand that one of the most expensive, apart from the blowout on the rig, is wellbore failure, wellbore collapse, stop pipe, wellbore instability, because it costs millions of dollars. For two reasons, I use the offshore situation. Imagine you have a rig that you're paying $500,000 a day, and then you get into the well and you're stuck. Two things happen. It's either you're going to be jarring to free the string. Sometimes it takes 1 day, 2 days, 3 days, sometimes even 1 week, depending on the nature. Or you will eventually cut the string, pull out of hole, you spend the whole of that money, those expensive tools, bury it, and then sidetrack. Or you could even do both. You jar, it doesn't work, you eventually bury. It's a very, very expensive venture that nobody wants to encounter as an E&P company. AI has come up with a format that will help us avert that. And how it does that in this very situation I'm going to explain, it helps you to stabilize the well, to completely avoid that situation where you're going to be stuck. Because it happens all the time. That is the most expensive venture in the drilling industry. This example is going to focus on a situation where we want to be able to determine the strength of the shale downstairs and know if our condition, our drilling conditions stipulated, we'll be able to maintain wellbore gap until we finish the project. We start on the conceptualizing of the research. You come up with a format. I'm drilling this well. I need to know what the shale is. I cannot do anything now until I know, okay, if I have to study the shale, what are the information I need? You look at the data. In this case now, we're going to take an inverse data and direct data. So in the inverse side, you look at logs. You take inverse logs of similar offset wells nearby. You take the sonic, the gamma ray, the density, the resistivity, and the neutron. For the direct measurement, to make sure that what your inverse tallies with your direct, you do what you call a cone penetration test, that's the CPT. You take core samples, you do NAP analysis, then you do the undrilled, triaxial test. That's compressing to see how it will fail. Okay. When you take this information, you put it in the AIML, that's the artificial intelligence machine learning system, which is what I take. You take all this data now and put it as your input. If you remember the initial algorithm I told you, the input, you take all this information and put it in the input, and then select the right and applicable activation function. Okay, it eventually predicts the strength of the formation. And how do you get to know the strength of formation, especially when you take cores on the surface? Because you can't take cores deep downhole. It has to be surface cores before you can tie it to downhole. At that point, the parameters that determine the strength of the formation are basically cohesion and then the friction angle of the rock. So when you take this cohesion and friction angle, you get it now. And then with those things, there are calculations machines will still do for you that will not give you the shear strength. The shear strength is the strength of that material, what you can sustain before it fails, because that's what you want to know. You want to be able to know that this thing can entail this kind of strength to this level before it fails, so that you don't exceed that level because of your drilling. In the direct now, you follow that, you determine the shear strength from the direct input. You go back to the indirect input now from the inverse, and then you take all the sonic, the gamma ray density, resistivity, neutron, and whatever rock, depending on what you're doing, and put it back now in the deep neural network. The first one was just a shallow neural network. Yeah, so the shallow neural network. Now you take it to the deep neural network because you're going to have large amount of data. Imagine you have all these logs, there are 5 logs here, and you're taking 5 of them for maybe 5 locations. So 5 times 5, you're taking a 25, and each of these logs have something in the range of 20,000 data points. So you're talking of 20,000 times 25. That's a huge amount of data. You cannot process it using shallow neural network. So you want to call it deep neural network. The difference between a deep neural network and a shallow neural network is the number of hidden layers you have. That's basically the difference. Okay. Now you put it in the deep neural network, tweak it using the hyperparameters. The hyperparameters are parameters that you put, and it varies depending on the kind of job you're doing. Okay. And then it eventually outputs to you the unconfined compressive strength. Downhole of unconfined compressive strength from the cause on surface shear strength. They're basically the same thing. They have relationship. The relationship between them, depending on whether it's hard rock or total rock, will be half. Okay. Unconfined compressive is 2, shear strength is 1, depending on the rock. Okay. This is what I've said as for hard rock. Now, these two of them now, by the time you mix them together, using the AI, put them together now to balance them and make sure that both of them, the predictions are correct. You now come up with a phenomenological predictive model. A phenomenological predictive model, because the values you got were taken from things, phenomena you observed. Their core samples, the CPT, the lab analysis, and the triaxial test. Now you've gotten what they call a static model. It tells you at depth XYZ, you're going to get unconfined compressive strength of maybe 100, kilopascal, for example. But that's not what you want. We're talking of dynamic system. As we're drilling, we want to be getting information on the fly and making decisions on the fly. How do we do that? You now take this model again and put it in another AI unit they call the model predictive control. What is the difference between the model predictive control system and the deep neural network? Simple. The model predictive control system has 2 or 3 advantages. It's still an AI system, but in this case now, it allows you to give a constraint. Let's say, for instance, you're looking at shale. We know that shale has strength within a certain range. So you're going to tell it now, okay, as you're processing this thing now, make sure that when you get to shale, if the strength, let's say acceptable shale, let's say cohesion, okay, is between 25, for example, and 45. You would not tell the algorithm, say between 25 and 35, accept. Anything above, at 25 or 45, sorry, anything above 45, flag it. You can know it's abnormal. That's for the strength. You can also go back and then say, okay, now that we know that shale is not porous, but it contains some fluid that are not connected. Shale is not tortuous. Tortuous in the sense that the cells, the void that contains fluid are not interconnected. And even if it contains fluid and fluid moves in it, they don't move through diffusion, they don't move through flow. What we call absorption, adsorption, as compared to absorption, AB. Okay, they use osmotic transmission system to generate pore pressure penetration in them. Okay, so you also put that condition. So, okay, if you have this kind of situation, using for instance, your gamma ray to tell me, okay, this is shale, this is sand, this is that, you put all the limitations, what we call the constraints. Don't exceed 25, and then also put limitations. Okay, make sure if it's shale, peak. If it's not shale, eliminate. By the time you put all this in now, you carry the phenomenological. We're going dynamic. Don't forget, the initial one was static, which is what we used to do. But now we're going dynamic. You take that dynamic, the static model, and put it into the model predictive control system that is not dynamic, and then it starts to predict at every instance, maybe every 15 meters. Or every 10 meters, or every 5 meters, or every 1 meter, depending on the level of accuracy that you desire. Now, let me just do a little bit of explanation how the model predictive control works. The model predictive control, I'll give an example, like when you're driving a car, okay, there's a vehicle ahead of you, you want to overtake that vehicle. You accelerate. Your plan is as you overtake this vehicle, you go into the front of it, and then you continue your journey. And then you accelerate. All of a sudden, you notice that the vehicle in front of you slows down. You adjust your speed, either to increase it so I can pass faster, or you reduce it so that you go back and you. So what does that mean? It tells that you're using what they call receding horizon evaluation. That's what the model predictive control does. It doesn't look at the whole big picture and predict everything. It divides it into segments. Okay. For instance, like I said, if you're overtaking a vehicle, you look at the vehicle in front of you. I say, okay, if I overtake it, I'll give it like 5 meters before I pull in front of it and continue my journey. So your evaluation now has been done within 5 meters ahead of it. Now, when you pull over, by the time you accelerate, you want to overtake the vehicle, and you notice that the vehicle either slowed down or accelerated, that 5 meters that you initially planned does not work again. you now reevaluate depending on what you decide, whether to slow down or maybe that's okay, like, go faster and give it 10 meters. You change your horizon. So you go back to the new horizon and start working with that new one. That is the way the modern predictive control system works. It takes at a certain horizon, works on it. Maybe in terms of distance, it takes like the first 5 meters, processes the data out there based on what you've given it in the model, and then comes out with 10 outcomes, but uses only one, the first one. And then it goes to the next one. Let's say you have meter 1, 2, 3, 4, 5. It takes meter 1 and processes it at meter 1 and gives you an answer. When it goes to meter 2, it takes 3, 4, 5, 6. When it goes to meter 3, it takes 4, 5, 6, 7. When it goes to meter 4, it takes 5, 6, 7, 8. Just like that, what they call receding horizon. That way, it's able to use history, and not just history ones, history in different situations. Because in meter 1, it took 1, 2, 3, 4, 5. In meter 2, it still takes another 2, 3, 4, 5, 6. Like that. So it takes what you are taking before process, but gives you the answer for only meter 2. If anybody doesn't understand, maybe we'll get to the question and answer, ask, and then I can clarify it. So that way, it goes through things using historical data to better its prediction each time it makes an advancement. That way, your result becomes very robust and a lot more detailed when it's outputted. Having said that, what is the impact and implication of all these things if it works the way it's working on our system? It's simple. I've divided it into a couple of things: safety, risk reduction, operational efficiency and cost saving, environmental sustainability, and work transformation. I'll start from the bottom. If systems have to work the way it's working, like I've just explained now, how does the workforce now fit into that niche? Simple. They are going to be changing tools and skill requirements for drilling personnel. It means those who are in that area will now have to change yourself. You have to do things, for instance, you have to understand AI. You know how to do things like coding and get a fair knowledge of how coding works and how computer programming works. Those skills are divided into different subsets depending on what you want: AI engineering, data sciences, and then all these things, apart from getting those skills, it will now augment the understanding of human expertise and, build our capacities better. Environmental sustainability, reduce the metal footprint, still optimize well design. When you take all these things we've just said now and apply it, and it works out the way we want, you notice that unlike those days when we used to drill one well, the welding work, we pull out a hole and then drill another one again. Meanwhile, you brought cuttings, and all those cuttings have impact on the environment. You bring mud, all the mud you bring definitely is going to have impact on the environment. With all these things, now you reduce that footprint, you reduce the mud, you reduce the cutting, you reduce contact with the well, you reduce everything. And automatically, because they go into the environment, what goes into the environment is reduced. And when you reduce what goes into the environment, what are you doing? You're creating a better sustainability situation for the environment. Operational efficiency, it's very obvious, and cost savings. Optimize giving parameters and reduce non-productive time. When all these things work, pipes won't fail the way they normally fail. You're not going to have well stability. So if you plan a well, for instance, now for 1 month, you find out that you planned that well because you didn't have any failure, you hit your target of 1 month. But elsewhere, we used to plan wells. We had failures, there was a stock pipe, we had to go back and redo it. And 1 month, I've been in a situation where 1 month turned to 6 months. And you're paying the rig rate. Imagine if it was offshore, you're paying $500,000, you projected for 31 days, and now you're spending times 6. Awesome. It's not something everybody wants to get involved in. Generally, the last one in that section is proactive maintenance. It avoids catastrophic failures, also saves a whole lot of time. Then safety and risk reduction reduces human exposure to hazardous environment, because when you do all these things, for instance, on the drill floor, you don't have to have humans slapping pipes and clinging pipes and then latching pipes and tongues and spinning. No, because machines these days will do all those things. The robotic arms, the ROVs, they go down to the subsea level where you have the wellhead under the ground and do all the machine. That way, human is not involved. And when you're not involved, what it means, you're not exposed. And when you're not exposed, there will not be a hazard for you. Proactive identification and mitigation of drilling hazard. Of course, I mentioned that before. Lots of things that can happen. For instance, wellbore stability, instability, failure, because the shield is sucking. With the data you're getting with AI now, you're getting signals per second. You're getting the hydration, you're looking for pressure penetration, you're getting swelling, you're getting radius, you're getting the gas. You quickly see all this in automatically, it calculates everything like before. You have to take your go back to the office, calculate it, come back, and then make changes as we may require. But with the AI on the fly, as it's seeing the signal, it's telling you you need to reduce your weight on beat, you need to increase your flow rate, you need to increase pressure, you need to reduce blah, 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 depending on what the situation is. It adjusts it on the fly. That way, he identified the issues and kicked in the mitigating measures immediately to prevent that incident occurring. Sounds very good. Sounds very nice. Sounds very good. But like every other thing in life that is good, it comes with its own challenges. What are the challenges that AI brings to the table? Data quality and availability. Remember what we said, when you're doing a well, petrophysicists, geologists, they come together, bring the downhole map and all these things, the models, they look at it before they build everything. What if the data is not correct? Because junk in, junk out is part of AI. It is only going to work on algorithms. And the algorithms are the signals, are the sequence of operations that, if you remember what I mentioned before, it has to be precise that it is going to follow. If your data is not good enough, it means your output is not going to be good enough. What does that tell you? It tells you that data, clean, good data is a challenge because you need to make it that way for us to be able to use it and give us the kind of results I've portrayed now. Data security, ownership, and accessibility. I don't need to be there. In these days when you have cloning everywhere, when things go digital, all of us know Internet of Things. Can anybody access it? If it's in your file in your office, of course, nobody's going to touch it. But once you get into the computer with Internet of Things, is there a possibility for hack? Yes. So it becomes a concern. That's what's the challenge. Then trust and adoption. Building trust in AI systems through transparency and interpretability. How does trust come to play here? When you write programs to do exactly what you want to do, if the programs were not transparent in their evaluation, the programs were not transparent in their evaluation before they wrote the codes, of course, you sell it to anybody, they use it. Only the programmer knows, but the results or tweaks inside will not be as desired by the user. So that factor is a very, and guess what? It's not something, excuse me, it's not something you see immediately. It might take a couple of years before you notice it. So that trust and transparency, very, important. Then changing organizational culture and mindset to adapt to AI. Of course, these challenges we discussed, other people know it. And then the fear of, am I going to lose my job? Is it going to do this? Is it going to be very expensive? No. People need to realize that AI is only a boost. I call it a boost because it will still do what we're doing now, but magnify it 10 times. We can still retain the people in there, spread them out, put them different skill posts, and they'll still be there. Then regulatory and ethical considerations, adhering to safety and environmental regulations with AI systems, and then ethical concerns and reliability, decision, accountability. These are things that regulators will want you to comply with. Of course, we just have to do that. Then continuous learning and adaptability. Like I said before, AI system does the task today. I use a field, for instance. We build the AI system, it drills in the first well. What to do now, I do a regression compared to what we projected before, and it gives you something like maybe 75%, conformity. It sees that by the time you drill the next well, it gives you 80% conformity. By the time you drill the next well, it gives you 95% conformity because it has learned from history and is adapting to the field. Those are the challenges that we have, that AI have to cope with to be able to get to El Dorado as we so desire it. Look ahead. With all this happening, what do you think the future is going to look like in the drilling sector? We see a situation where AI-enabled drilling automation will come to play. What does that mean? It means from cradle to grave, apart from operators, the AI is going to do everything. You set up the rig, AI assists you anyway in setting up the rig. You set up the rig, you put everything, and then you start to drill. And from the time you spot your well, to when you complete it, it keeps catching the data and catching the data. And when it catches the data over maybe 10, 20, 30, 40, 50 wells, and that captures everything. It's able to tell you from day one. Now, let me not even the drilling. It's able to tell you from where you do your seismic that this is what will be required, this is what we do, this is what we wear, and from the actions that perform, say, when this is getting, I'm going to perform these things, and that's one. That's the integrated operations and the AI decision support. That concept now is going to generate, is going to create what they call the integrated operation centers. Because now you now have people, man, for instance, the geologists, the geophysicists, the seismic people, they have their own thing. They bring all this data, a center will not integrate it, who are going to be the AI people, and then execute it on the rig, do your drilling. We also see a situation where AI will not be used if all of these things turn out as we say, which is going to turn in no recent time, because now we have a software called, we're looking at, apart from the AI, which is the artificial intelligence, we now have the AGI, still in the beta mode, which is the artificial generative intelligence. It's called Sora. A lot of us know it. You can use it now to generate things, from pictures to movie. Like I said, it's still in the beta, but it has started like any other thing. It has come to stay. So once you are able to come out for a situation where we do, it comes to stay and it's get rooted, you can sit down now and take all the data from the histories and everything and the facts you have, put them and run them through the process you said now, and then the system will be able to generate over time what will happen. This is especially going to be useful in ERP industry when it comes to production, because you're looking at, okay, I'm producing at this rate. This is what I want. My decline curve is going to be able to tell you what your decline curve is going to look like. It's going to tell you when you start raising your curve, when you get to plateau, when you start dropping, and when you should be able to abandon the well in a way that is ethically acceptable and environmentally friendly. Conclusively, for everything we say now, AI is transforming the drilling world through data-driven decisions, automation, and novel applications, just like I've pointed. It's also enabling safety, efficiency, sustainability, and workforce transformation. For the workforce now need to get to new skill pools and get better at what they do, expand their scope of knowledge. AI and artificial intelligence potential to revolutionary drilling industry. AI, like I said before, is only a force multiplier augmenting and amplifying human capability, because what the AI does, AI did not generate. Is a human algorithm developed by human being that did it. Even if algorithm, right algorithm, is human being that wrote the algorithm, that made it understand the fact that he had to write algorithms. Realize vision for autonomous, optimized, and intelligent drilling. Just like I said, if we get all these things right, and we're going to get it right for sure at the rate we're going, when I don't know, but for sure we're getting there. You notice that autonomous, optimized, and intelligent drilling is by the corner. It's coming, for sure. Now, what do we do to get on the driver's seat and to benefit from this? The industry must first of all take proactive steps. What are the proactive steps? They depend on what you do and what the philosophy of the company is. But one, you must equip the people with the relevant knowledge required to be functional in the AI space. You must invest in robust data infrastructure, servers, transmitters, things like Apache Flink, to be able to move data from downhole to the surface at lightning speed as compared to what we have now in NWD and LWD. We must establish comprehensive AML engineering capabilities. We have to augment. I just heard the other day that NVIDIA, one of the greatest chip makers, are come out with a chip now that is like 3 times faster than the best chip we have now. Things like that have to come because we need data to be transmitted at the speed, if possible, faster than lightning. They will cultivate trust, transparency, and collaborative adoption. Like I said, it's very important that people get to trust what you're doing, giving to them, and believe in you. That way, we can take you and swallow you, hook, line, sinker. Because if it's not that way, yes, it might give you results, like we're getting results now, even when we're doing it the old-fashioned way, but the results will not be optimal. They will embrace AI not as a threat, but as a powerful tool to enhance human capability. It's not something that is going to make you lose a job. It's something that is going to make you work better and smarter. So we don't need to be straightened, so to say, because a lot of people it's been highlighted, concerns, oh, I'm going to lose my job. No. If institutions, companies put their staff in the appropriate knowledge bracket, you only upscale and multiply the effect of that personnel, and of course, it transfers to multiplication of the returns of that investment. At that point, I say, thank you for attending this AI presentation. It's been nice talking with everybody and listening to everybody. I'll hand it over now back to the coordinator or the anchor, and then we can take the questions and answer. It's your turn. Thank you.
Thank you so much to our amazing speaker, Noble Bariza, for that very, very, very engaging lecture. So this juncture, ladies and gentlemen, it's time for question and answers. And of course, we have about 10-15 minutes to respond to all of your questions. So please, we are on the chat box now. If you want to ask a question, you may raise your hand or drop it on the chat box and I will read it out. So please, we are monitoring the chat box for all of your questions and we would be so pleased to answer all of them. I think starting the question or the comment section, we'll start by listening to a man that is passionate about tech and AI. He's on the call. He's been on this call from the very beginning. He's going to give the first comment. And I believe while he's giving his first comment or perhaps a question, others would also have their questions being dropped to the group. I'd like to welcome the CEO of Cypher Christians Limited, Mr. Thangood Egbe. So let's hear your response or a comment or a question you may have before we continue with other questions. Mr. Thangood Egbe, please. Are you on the call? We'd like to hear from you, sir. Oh, since he's stepped out. Okay, so we are taking question and answers now, ladies and gentlemen. Please, we'd like to ask that you drop your questions and answers. We also pleased that we have the section chair who joined. We celebrate you, Engineer Victor Anoche, for being part of this. So I want to believe that if there are no questions and answers, everybody understood everything that was taken. That's up, Jumbo, if you can hear me. You dropped a chart at the beginning of the event that you would love to find out how AI would enhance your practice. So, Dazok, can you unmute your mic? Let's hear your experience or what you can say about the lecture. Did you get everything or do you have any questions to ask? Dazok. Jumbo.
Good evening, everyone, and thanks to the speaker for a wonderful presentation. I think the session was very enlightening. From what I heard, one thing that we can apply immediately is around real-time monitoring and decision-making. I think that's a low-hanging fruit for immediate application. And I'd like to see that, how that runs immediately with the current technology that we have. I know it's going to take a while for all the things that the speaker has talked about to be implemented in our current environment. We're still dealing with quite analog rigs, especially in the land and shallow offshore space. Maybe a bit more technologically advanced rigs in the deep offshore space in Nigeria. So, but for decision making, I think that we can implement almost immediately, and that cuts across all the terrains. So, thanks for the presentation.
Thank you.
Okay, Section Chair just dropped a chat. Insightful presentation. Thank you, Nubo. Okay, awesome one. Okay, we see a hands raised. To become a zone.
Yes, good evening, everyone.
Go ahead.
Okay, good evening, everyone, and thank you, Mr. Noble, for a wonderful presentation. And also special thanks to the section for coming up with this particular presentation. I must say is a very interesting one, and it's something. Please, I hope you can hear me, right?
Loud and clear.
Okay. and it's something that I'm also very much interested in. So I actually joined this presentation from a rig. In fact, to support what the presentation is all about, I'm joining from a rig in northern Nigeria where some exploration is currently going on. And while we are discussing, I'm trying to play back all of this in my mind and how it's going to apply to the work we are doing at the moment. So a quick question on that. My question is basically how would AI, you know, I saw from, I didn't join from the beginning, so my apologies if my question might take you back. From the part I saw, you mentioned that AI is going to work with data-driven solutions. So currently we are dealing a wildcat, not a wildcat per se, but a well without so much information or with so less information. So how would AI now come into play at this time where we have not so much information and we are faced with more uncertainties than before, or in a place where we have a wildcat today where we have absolutely nothing, absolutely no information of the geography of the geological formations and the entire area. How would AI now come into play, especially when it's meant to be driven with data and there is no data? I think how would AI powered drilling come about, or do we now revert to manual drilling mode? And you know, I'm sure you get the point I'm trying to make, sir. Please, if you can, I'd really love to hear your view on that. Thank you.
Okay, thank you very much. That's a very, very good question. And first of all, before let me just lay background. You don't build something on nothing. There must be something before you can build something. As far as I'm concerned, to the best of my knowledge, we don't have drilling experience in the north. That means you're more or less doing a wildcat, so to say. Now, how does AI come here? It does come in. If you remember the schematics I showed, just hold on. Here, okay? I told two things. Sorry, my mouse is okay. When we're doing this evaluation, we said there is inverse and direct data gathering. Inverse, we will have the logs, because you've not done any drilling there, you don't have logs. So you cannot do inverse. But you could do direct for now. You can take cores, you can do lab analysis, you can take triaxial tests, you can do lab mechanical and chemical evaluation, and then capture that data. Then from that data you have captured, you send it to the AI with the artificial intelligence, okay? You can use any of the formats depending on what your company does, and it will be able to predict for you what the surface conditions are. Now you have the surface conditions. We can still go ahead and do what I would call a temporary model, because before you went to the drill, they did seismic evaluation. You go to that seismic data file that has been given, and then AI can still build a subsurface model from that. Okay, now you tie the subsurface model to the model you get that you built with the cores that you took directly. It will give you a guide for now. Because what do you want to do when you're drilling? First of all, you want to understand the stress profiles downhole. You want to understand where the liquids are. You want to understand where the soft sands are. You want to understand where the shales are. These are the important things when you're drilling a well, especially hydrocarbon well. This will give you, by the time you're able to take this to and couple it, it will give you what you want, at least for now. But like we said, AI is a system that is learning, that learns over time. It will get better as you get more data. You finish with the wildcard and go to the next one, you get data. By the time you take this data you projected here, you get the first thing, and then benchmark it and do a regressional analysis. You'll be able to see to what limit they tally. 70, 60%, and then you'll be able to see where the gaps are. When you go into the next one, you bridge it. So for sure, my brother, as it stands now, you can still use AI. It might not give you the ultimate because of your data limitation, but will give you a guide that is better than what ordinary humans will do. Does that add value to you, please?
Yes, Yes, with the core analysis and the other forms of direct methods of getting data, I think that answers the question. Yes, I totally agree with you, sir. Thank you.
Okay, so you have two more questions on the chat box, and this will be our final questions for the day. If you have more questions, you can advise to search us his profile on LinkedIn, and you can send him a DM. The next question is from Abdul Malik Ajibade. In the terms of data processing, what challenges and techniques are unique to the diverse data sets generated during drilling operations? Should I take that again, Oganobal?
Yes, please take it again.
Okay. Abdul Malik says, thank you for your wonderful presentation, sir. In terms of data processing, what challenges and techniques are unique to the diverse data sets generated during drilling operations? What challenges and techniques are unique to the diverse data sets generated during drilling operations?
Drilling operations. Okay. I'll start for the challenges first of all. When you're doing drilling operations, first of all, like I said, AI, the more the merrier in terms of data. The more data you give it, the better for it to make predictions or profile solutions that are a lot more accurate. How does that become a challenge when you're drilling? It will depend on the sensors and the kind of things you want, what we want to do. I'll give an example. Assuming that you want to look at, if you're drilling something like a thin layer, you want to do horizontal well in a layer that's like maybe just 1 meter. That means you want accurate boundary condition. You want to see where the reservoirs are, so the boundary will likely be, like we will do it now. No. You want to know precisely. It means you're going to be running systems that are able to capture precision. You're going to be running precision systems. That's the challenge you're going to have. Running a typical, for instance, spontaneous potential to see where boundaries are, and then when you run things like gamma ray, okay, they're two different things. So the challenge you're going to have there, for instance, for this example, is precision material. Then what are the techniques? Of course, depending on what you want to do. Depending on exactly what you do, that will determine the data you want to collect, and that will also advise, the techniques to adopt. For instance, now, if you want to do, like I said, you want to determine the boundary, okay, upper and lower boundary of the reservoir, what are you going to do? You took the challenges, you get the precision material, and then the technique is simple. When you run downhole, normally you log upstairs. But in this case now, I will advise that you log up downstairs and then do the final log upstairs and then tally. Because if it is a precision tool, as long as your cable is going at the same speed, chances are that you will not have significance. Does that help in any way?
Yes, sir. Thank you so much for the response, sir. Thank you.
Okay. The last question for the day, and then wrap up question and answers, is from Osomo Adeboye. Hi, good evening. I would like to know the efficiency of AI in analyzing drill pipe twist tendencies. What probe could be employed in ascertaining that? I'll take the question again from Osomo Adeboye. I would like to know the efficiency of AI in analyzing drill pipe twist tendencies. What probe could be employed in ascertaining that? Okay, that's the question, sir.
Okay. First of all, for those who probably are not too familiar with the rig, what is the drill pipe twist? A drill pipe twist results when the drill pipe rotates beyond the limit it should rotate. There's a twist. Okay. Now, for every drill pipe that is made, it is given a twist rating, a burst rating, and a collapse rating. So, for you to be able to determine if that pipe, you will get a twist torque, just like you measure the torque range Once you get the torque wrench on the race floor, as you twist, the torque wrench is going to tell you, you set a limit, okay? If it's for a dynamic system, like I said, you also use what they call the model predictive control. After you set your limit, you put it in the model predictive control. The model predictive control will tell you dynamically at every instance how it goes. But the most important thing is that you must get a sensor that's able to sense the twist of that pipe, even if it's 1 mm. Once you get a sensor that's able to get that twist of the moment and 1 mm, the job is done, because the original manufacturers, OEM, already give you the ratings and the twist limit that the pipe can stand. I hope I was able to help.
Okay, okay. Thank you, thank you. I can see some virtual applauses for you. You can drop your comments. Thank you so much, sir, for the lecture. I believe we all enjoyed it, enjoyed and learned from this. Thank you so much, sir. Okay. So, sir, any final words before we switch over to the next? Any final words?
Well, because we're going into a world that is basically, to my thinking, is going digital. I will encourage not just people in the drilling, because we've said this in drilling because we focus there. I will encourage anybody who is in the industry to ensure that at whatever level they are now, key into machine learning, understand the basics, because the basic is universal. And then when you go into your specialized niche, your domain, it's still going to be the same. The only thing is that the inputs are going to be different. For instance, if you're a reservoir engineer or a seismic interpreter, you're going to be focused on image recognition and interpretation. The algorithms are going to be different from somebody who is into wellbore stability and rock mechanics. But the process is the same. You will get an artificial neural network system, depending on the kind of system you adopt, you choose to learn, or your company adopt. You get an input, you get hidden layers, you get output. The philosophy is the same. So my first advice with anybody is go and understand the philosophy and then pick it up from there, depending on your desire and the opportunities that come your way. Thank you.
Awesome, 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 awesome. Thank you so much. Thank you so much. Please, if you have some virtual applause, please, you can drop it for Organobel, and it was an amazing, amazing one. Okay, ladies and gentlemen, we have come to the end of the monthly technical meeting. On your screen, just in case you're not a member of SPE, this is a Chiron call. You should join the SPE. We have so many benefits for professional members. We also have several benefits for student members. Just send me a DM, just send us a chat either on LinkedIn, on Facebook, on Instagram. And of course, we would respond to you on how to be a member of SPE Abuja section. These are all over social media platforms. My email is the first, my YouTube. Now, this technical session was live streamed on YouTube, and of course, all of the past sections have all been on YouTube. You can always go back and refresh your memory just in case you have any kind of questions to ask. Facebook, LinkedIn, and of course, Instagram is always available for all information the section may have for you. Okay, we have events coming up in SP Nigeria Council. The first is the Women Leadership Lecture Series. And of course, that will take place on the 8th of March in Eco Hotels and Suites. Check our social media pages, and of course, you can register to be part of this event. We also have the Oloibiri Lecture Series and Energy Forum coming up on the 28th of March, 9 a.m. at PTDF. You should register and be part of OLEF. Of course, the theme is sustainability in the Nigerian energy sector. It's going to be very, very engaging. On the YP level, we have several young professional events being cooked up. Of course, you should participate and be part of them. Visit our social media pages, like I said earlier on, and you'll see the links to register and attend this event. At this juncture, we'd like to have a closing remark. No other person will take the closing remark than the young professionals chairperson of the Society of Petroleum Engineers Abuja section, Mr. Chizom Okoye. Please, the stage is yours for your closing remarks, sir.
Yes, thank you very much, everyone. Good evening. Thank you so much. Thank you to the section, first of all. Thank you to our amazing Nobel speaker, Mr. Nobel Bariza. The insights from the presentation were very, 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 very on point. Not to blow trumpets, but as somebody who actively work in the data space, um, again, it made me reconnect with the various algorithms we have been doing on a day-to-day basis. This expose is really, really important, and I hope we can always continue this conversation afterwards here with more members showing more interest with this. I would like to leave us with some very closing keywords, not taking anything out of this beautiful presentation. One of them about our model and our model controllers. Um, then two other important areas, and I'll quote verbatim, one from the words of David Water. He said, if Elon is wrong about AI and we regulate it, who cares? If he's right about AI and we don't regulate it, we would all care. So it means that we have to get involved, we have to speak, we have to learn, we have to apply that. This might be from a not too positive side, but reverting quickly to the positive side, taken by the president of the LDK Advisory Services. She has this to say: the reality is that being unprepared is a choice. The benefit is when we see AI as a tool, not as a terror. Very important. We see AI as a tool and not as a terror. The most important general purpose technology in this age, in this time, is AI, and more suitably, generative AI. We should latch upon this because if we don't and the train leaves us, we become unqualified to lead and contribute to the development of the society and the world at large. Thank you very much for coming. You would get to see more very interesting conversations on AI. I'm sure Mr. Nobel would like to share more insights, even and do deep dives, as I would come to him to take the young professionals on deep dives sections too. So thank you, and not forgetting all of these section officers. I can see Dr. Ike on the call, and a host of many others. Thank you, and do have a very wonderful evening. Mr. Akpan, thank you too.
Thank you. Thank you. We gave you time. I believe we have given us another technical session. Thank you so much, Chisholm Okoye. Ladies and gentlemen, it's time for a very quick photo session, and we are done for today. Okay, sir. Okay, sir. Please.
Okay. I just want to also take this time to say a very big thank you to Mr. Nobel again. Thank you for the opportunity. Thank you for coming. But I want to also say thank you to somebody who ensured that we had Mr. Nobel here. That's my friend, my brother, and my colleague, Dr. Emeka Okoro. Doc, thank you for facilitating this. Like I've said to Nobel on the private chat, we'll be having a whole lot of this engagement, especially with young professionals as a plan for future events. Thank you so much. I can take it up from there.
Okay, thank you so much, Oga Emmanuel Okoro, for the amazing stuff you do for SC Abuja section. Okay, ladies and gentlemen, please kindly appeal to turn on your video cameras. Let's just have a shot of all of us, an AI photo shot. Thank you for being part of this event, and then we wrap it up.